Assalamualaikum warahmatullahi wabarakatuh and good afternoon everyone. My name is Zainul Amirul Rashad bin Zainul Abidin, metric number 207531, alongside with my group members Ahmad Zafran bin Zulmajdi, Ng Kian Tiong and Fuseyin from Group 6. We are going to present the application of integration in engineering in focus of RMS value. So before we proceed to how we find the formula for the RMS value, it's best for us to have a little bit knowledge about what is actually the RMS value means. So RMS stands for root mean square value. Okay, in electricity, there are two types of current or voltage, which are direct current DC, and the other one is alternating current AC. These two type of current and voltage differ from how they carry the current and voltage in a circuit. Uh, Besides that, we also can look how they differ from the graph, which the DC will have a straight line graph, and for the AC, it will have a waveform graph. For example, 5 volt DC is not equal to 5 volt AC. So, how are we going to find the equivalent value? So, then RMS is used to find the equivalent value, and it is also considered as effective value of DC. Before this, we can see that for 5 volt AC current, 5 volt AC is not equal to 5 volt DC. So to find the equivalent, we will use the RMS value, which will give the same effect as 5 volt DC. So if we have a 5 volt RMS value of AC voltage, it is equal to 5 volt of DC voltage. And this will bring the same effect as DC voltage or current. And for how we find the formula, I will pass it to my group members. Thank you.
My name is Fuseyin and my matrix number is 205526. And now I will explain about the objective of this application. The objective of this application is to apply the concept of mathematics to find the RMS value in AC current, to learn the way of solving the calculation in engineering and calculate a formula of Vrms and Irms. Besides that, it is also to acquire the knowledge of facts, concepts, and theories of mathematics which is used in this application.
Hello guys, my name is Ng Kian Tiong and my matrix number is 206390. So now I'm going to present the main point and discussion part. So now let me introduce you the equation of RMS value of alternating current. So the formula will look like this. IRMS equal to I peak divided by square root 2, or you can write 0.7071 times I peak. So what does IRMS means? IRMS means the root mean square value of alternating current, and I peak means the peak value of alternating current. Alright, next we go to the equation of RMS value of alternating voltage. So the equation will look like this. Vrms equal to V peak divided by square root 2, or you can write it 0.7071 times V peak. So Vrms means the root mean square value of alternating voltage, and V peak is the peak value of alternating voltage. So this is the graph that shows us the difference between the peak value and RMS value. So from the figure above, we can clearly see that value of RMS will always smaller than the peak value. The figure above also can apply to alternating current. Well, you can see this is a voltage. Hence, we can conclude that peak value is 0.7071 times bigger than the RMS value. So now I'm going to show you the derivation of root mean square value formula for alternating current. Integration method is used to obtain the formula of RMS value by finding the area under the graph. Note that this formula only can be applied to sine wave or cosine wave. So now let's take a sine wave representing either current or voltage with peak value A. So this is the equation that we are going to use. Yt equal to A sine Wt. So T means the time, W means the angular frequency, and the A means the peak value of function Y. And this is the graph of function Y. And this is the amplitude or peak value A. According to the definition of RMS value, which is the square root of the mean value of the square function, hence we can conclude that the equation will look like this. So first of all, we need to square the function first. So we square the function. After that, we use the integration method to find the mean value of the square function. So this is the mean value of the square function. So lastly, we need to square root all the things. So we square root all the things. After that, we substitute equation 1 into equation 2. So equation 1 is y equal to a sine wt. So we sub equation 1 into equation 2. So now we get this new equation. After that, we put the 2 go inside into the bracket. So now we get the equation 3. According to the trigonometry function cos 2 theta equal to 1 minus 2 sine square theta, from that we can easily find out the formula for sine square theta, which is equal to 1 minus cos 2 theta divided by 2. Therefore, sine square omega t is actually equal to 1 minus cos 2 omega t and divided by 2. After that, we substitute equation 4 into equation 3. So after that, we will get this equation. So after we done the integration, we will get the new equation. So since we already know that omega is actually equal to 2 pi over t, so this uppercase t means the period, okay, the period of the waveform. So now we try to express the omega as 2 pi over t, and now we sub the uppercase t into the lowercase t, and we sub the 0 into the lowercase t again. So now we got this equation, and eventually we will get this final answer, which is a over square root 2. And hence we can make a conclusion that y-RMS is equal to a over square root 2. Since y can be either current or voltage functions, therefore we can conclude that I-RMS is equal to I peak over square root 2, and V-RMS is equal to V peak over square root 2. So by using that relationship, we also can calculate the peak value of a current or voltage function. So I peak is equal to square root 2 times I-RMS, and V peak is equal to square root 2 times V-RMS. In general, in order to find the formula for calculating RMS value, the function y must first be squared. After function y is squared, the area under the curve is found by integration. It is then divided by t, the length of circle or the period of the waveform, to obtain the average or mean value of the square waveform. The final step is to take the square root of the mean value. So now let's discuss about the application of RMS value in AC circuit. One of the applications of RMS value is to calculate the mean power that dissipated from a circuit. This is due to RMS value of an alternating current can also be defined as the value of the direct current that dissipates heat at the same rate as the mean power dissipates when AC floats in the loop R. Now we try to imagine that we have a AC circuit now, and inside the AC circuit we have the loop R and the AC power supply. So we assume that the instantaneous power is equal to I squared times R, where I is equal to current and R is the resistance of the loop. So mean power is equal to mean value of I squared R. So that makes sense? Okay, next. Since R is a constant and hence mean power is equal to mean value of I squared times R. So mean value of I squared is actually equal to the IRMS square. So the mean power is actually equal IRMS square times R. Furthermore, RMS value also widely used in the solving problem in series and parallel AC circuits, such as find the total impedance and voltage of the load in RL, RC, and RLC circuit. In the conclusion, RMS value is playing an important role in the AC circuit. So now we go to the example. So this is the example, and this is actually a sawtooth graph, and now we are asked to find the RMS value for this graph. First of all, we need to identify the period of the waveform first. So this red line means one circle, so to complete one circle we use 0.2 seconds. So the period is 0.2 seconds. Then we need to create the general equation of the waveform. So by using the linear equation y equal to mx plus c, the general equation of a sawtooth graph can be found. Okay, so first of all we need to find the gradient first. So after the calculating, we get the gradient 10, and we also can find the y-intercept, which is minus 1.0. So now we sub these two numbers into the linear equation. So now we got the general equation, which is v equal to 10t minus 1. So now we square the function first. Then we try to find the mean value of the square function. So lastly, we square root all the things. So eventually you will get this equation. After that, we expand 10t minus 1, 10t minus 1. So we do the integration. Then we sub 0.2 and 0 into the variable, and we got this equation. After that, we will got the value 1 over square root 3, which is also 0.577 voltage. So the 0.577 voltage is the root mean square value for the sawtooth graph just now. Notice that if a sinusoidal wave is given, we can calculate the RMS of voltage value by using the general formula, which is V RMS equal to V peak over square root 2, but it's not allowed to use this formula for a non-sinusoidal wave. The graph just now is one of the examples for non-sinusoidal wave, and its RMS value need to be calculated by using the integration method. So I think that's all from me. Thank you.
Okay, thank you for the presenters. Now I will continue with my slide. My name is Ahmad Zafran Mizumajidi, and my metric number is 208243. In conclusion, RMS value is one of the most important parameters that is used to describe the strength of an alternating current, which is AC circuit, as it is used to calculate effective AC power in a way that allows it to be compared to the equivalent heating value of a DC system of an electronic compartment by using an integral basic calculation. This is a common mathematical method for determining the average of a constantly varying value and keeps every constant varying voltage in one specific term that can be applied to either AC or DC circuit. This is clearly ensure that every component and source in a particular circuit are well managed without any overlapping, lacking or overpowering strength with just one summarized equation. I think that's all from me and from all of us. Thank you.